Hey everybody, my name is Mark, and today I looked at Kubernetes. So I wanted to share what I learned with you about Kubernetes, so let's get started. So what is Kubernetes? Let me write it down up here. Kubernetes is a container orchestration system. So I guess what follows is the question, what exactly is a container? Let me write that down. What is a container? So a container is an application that runs in a container runtime. So there's a lot of different types of container runtimes. A famous one is Docker or Containerd. Containerd, for example. So what is a container runtime? It is a sort of environment for executing containers. So it runs usually, it can run on Windows, Mac OS, or Linux, but usually Linux on Linux machines. So it is an environment for running containers. So containers, they are really lightweight. So pros of containers, they're really lightweight. Sort of easy to work with, easy to start, easy to work with. And you can run multiple of them at the same time. They can communicate with each other, right? Like anything you'd want, any kind of application you want to write, you can put it into a container and have it run, and everything should be good. So communicate, etc. So the question is, how do you create a container? Well, you create a container. How to create container? So from a container image. So a container image describes how to get the code, get the application code, move this over, how to get the application code, then also how to download the dependencies, how to download dependencies that the code needs, and finally, other setup stuff. Right, so once this stuff is downloaded, once you download dependencies and other setup stuff, then you from the container image you create. Well, technically the container image is the already packaged version. So you have like a Docker file or a container file, and then you build it. So let me technically, I will write technically. So you have this Docker file or container file, then you build it, and then it becomes a container image. And this is just an image of what the container is, and then you can instantiate it, so you can create as many copies as you want. Create create copies of it, and then this will create copies of it, and then here you have your container, I guess. And then what do you do with your container? You run it on your container runtime. So just say run in Docker. Okay, makes sense so far. So now back to Kubernetes. So what is a container orchestration system? So as it turns out, big companies really like containers. Why? Because containers, they allow you to break up your application. So here we have, maybe before in like 2000 or 2005, in the dark ages of programming, you had a really large application, really big, and it becomes really hard to manage. Really hard to manage. However, with the invention of containers, you can pretty much break up your really large applications into tiny little applications, and each of these is a container. and each container will be responsible for like, so you've broken your big application into lots of tiny applications, and it into basically, if you can manage to take your large application, break it into lots of tiny applications that you can fit inside a container, and then have the containers talk to each other, and that becomes your whole application instead of this really big monolith. So this is a monolith. If you manage to do this, then it becomes easier to manage, because you could like assign a team. A team is responsible for this container, and then another team is responsible for this, and then if you figure out how to talk, if you standardize how to talk between them, then the other team doesn't have to worry about the other container doing its job, or like, because all the code will be self-contained, so it's way easier to manage. Of course, it does come with some trade-offs, but that is a trade-off that people are generally happy to make. So what is back to Kubernetes? So what is a container orchestration system? Container orchestration. So the problem is once you start breaking up your containers into your application into lots of little containers, the containers need to talk to each other, and you need to have some sort of like overarching system that is actually managing the containers. So let me give you a couple examples of cases where you might need to, back out, where you might need to actually manage the containers. So number one, so what happens when you run a container, or like, let's say you create a container and it crashes. Maybe you need to like automatically restart it, right? I mean, before you had like one big application, it crashes. Maybe it's easier to manage because it's one application. But if you have thousands of containers, so what do you want to do here? You want to automatically restart it, right? Or maybe, and you want to make sure that the requests are not being sent to this container core anymore. You want the request to be sent to a different container, sent elsewhere, right? Or for example, here, let's just say you push a new version of your code. So then if you have a bunch of containers, you have thousands of containers, you need some sort of system that is going to push this code, to all the containers, The problem is, if you have a system that needs to be on like 100% of the time, then when you push the code to all these containers, you're going to experience an outage, right? If you push the code. So it would be nice to have a tool that like gradually upgrades all the code, on all the machines, right? And there's a lot of also way more other obvious use cases. So for example, if you want the containers to talk to one another, right? Containers talk to one another. This is obviously critical because you've broken your huge application, into lots of tiny containers. And the problem is the reason why we broke it down, or like we do need the containers to talk to each other. And the really big application, it was okay since everything was right next to each other, right? It was all within the same application. But if you have lots of tiny applications, I mean, the reason why we accepted the solution in the first place is because we assumed that the containers could talk to each other, right? Because the application, it has to rely on a bunch of interconnected moving parts, and this is kind of a requirement for the application. So they do need to talk to each other. So how do you figure out who to talk to? Like maybe one container crashes, so then you need to talk to another one, right? Container crashes, talk to another. Let me think. Yeah, and like all of these containers, you have also, for example, the containers are spread out across multiple, they might be spread out across the entire world, right? So like, question is like, which containers go where? Like how? So maybe you have like two different types of containers, and they have to communicate with each other, and they have to, let's say you have like servers in Japan, servers in the US, and servers in Mexico, right? You probably want every single one of these regions to have their own version of these two containers, right? You wouldn't want somebody in Japan having to communicate with a server in the US because that would take a long time, and there's all sorts of regulations also with your data or whatever. So you, if you wanted to spin up, these thousands of these containers, right? You have like, I mean, they're called nodes in Kubernetes. So a node is equal to a computer. It's not a container, or like a server. So if you have two servers in Japan, you want the Japanese nodes, right, to have a version of both containers, right? So little things like that. So let me show you what Kubernetes looks like. So hopefully Kubernetes is, let me just write, Kubernetes is built to manage all of this, right? So let me show you what Kubernetes looks like. So here's what Kubernetes looks like. So here are your servers or nodes. So here's one node. These are all like physical computers you rented out from like AWS or whatever, or it could be your own. So here's node number 1, and then here's node number 2, and here's node number 3. I think a good analogy is, let's just say, imagine this is like a ship. I mean, I'm not the greatest artist in the world, but you will have to deal with it. There we go. It's a ship. So all these are ships. So imagine in this analogy, a container is literally a cargo container, like a ship container that holds stuff. So a node can have multiple containers. So there's one container, there's another container, there's a third container. Maybe this one only has 2. And maybe this one has like 4. And these could be, all these containers could be doing different things, and they probably are doing different things. Anyway, so then let me talk about, so there are generally, so I think some other things I've learned. So I haven't gone too deep into Kubernetes, but each of these is running an application. So a node, a server, is running this thing called a kubelet. So a kubelet is a binary application that talks with the other containers. With the other, nodes, not containers. Those are containers, but these are nodes. So the kubelet, so each ship, each node has its own kubelet. So here is also a kubelet, and here is also a kubelet. Okay, makes sense? So then also there are these special nodes. So this is a I think it's called a worker node. Yeah, so these are worker nodes. So what is a worker node? A worker node is a node that contains only containers. So it only does work. But this could be like a special ship. Imagine this is a special ship, and we call this the control planes node. So this is a special node. So I will put stars next to it. Special. All right, let me write here special. So the control plane node, I think. So the thing is, like, we do need, when we make all these like containers, the way we orchestrate them, you can't just rely on the containers to orchestrate each other. You do need, like, let me just write it here, need a central area of command where you can do a bunch of things. Like, for example, you can add containers to existing nodes. So you tell a ship, hey, hold on, I'm gonna add an extra container to your ship, and there should be a central area of command that does that to existing ship. Also, for example, other things. If track, or let's just say monitor ship health. to make sure they're still alive, right? So if like half your nodes go down, right, then maybe you want to create new nodes, right? Create new nodes, or maybe you want to like restart them, or if there's like some error in the code, then maybe you want to roll back the version of the code that caused this crash, and that can be done automatically. Monitor ship health, and there's other things. I mean, in general, so all this information is stored in something called etcd. So etcd is a very simple key value store, key value dictionary store. So it has all this information: ship health, which containers are, which ships have which containers, sort of like all sorts of information like services, deployments, all this kind of confusing stuff. But pretty much every single piece of information is stored in this key value dictionary store. This special chip, it has special containers which do this. So these are like, let me just like draw them, color them in. So let's just say these are like special like command containers, and they can do that, these sort of centralized tasks, right? Like monitoring ship health, adding containers to existing ship, etc. So the other thing to know is that it's not necessarily true that you only have one copy of these. Not necessarily true. That there is only one copy. So there might be, what I'm trying to say is there might be several control plane ships or nodes. And they might even have the same functionality. They might have the same, you might have two control plane nodes that both monitor the ship health, right? And like, for example, in different regions, right? That there's only one copy of control plane containers. So you can have two ships. Can have two control ships. And the way these two ships communicate with one another is there's, I think, something called a rafts protocol. Rafts protocol. So it's a synchronization protocol for synchronization. And it makes sure that so both these ships have like their own version of the etcd. So here's the special container. So this one, so inside here, you will have an etcd key value pair, key value k1 v1, k2 v2, ... And then this one will also have its own etcd, k1 v1, k2 v2, ... So then, so here you have two control ships, and like I said, they synchronize. So the etcds usually between them, they talk to each other. So let me say they talk to each other to make sure their etcds are mostly matching, good enough within some error tolerance. So the whole point of all of this is we have a bunch of these nodes, a bunch of these servers. We load the nodes with containers, and like how many containers we want. Also, this, I forgot to mention this, let me write down here. So also a very big use case for Kubernetes is, let's say, for example, you have a sudden influx of traffic. Maybe it's like 4 p.m. or something, and a bunch of users got home from school, and now they need to use your application. So if, you could tell Kubernetes, hey, if our servers are getting overloaded, make some new ships, right? Make some new ships. If there's too much going on, make me some new ships. and add the same containers to there to make sure it doesn't get overloaded. Or if there's too little traffic, maybe let's remove ships so I have to pay less for server costs, right? Which are for ships that aren't getting used. So hopefully that makes sense. So Kubernetes is a tool for managing all these containers that are on the nodes. And I should also mention one of these central area of command. One of these special ones is the Kube API server. So the Kube API server is a server. So this is a server that, so Kubelet, the Kubelet application interacts with, Kubelet and user interacts with. So if you want to create, for example, a new ship, then it goes through this Kubelet, then it goes through this Kube API server, and through this sort of central area of command kind of thing. So if you want to create a new ship, if you want to create a new ship, so it goes through the Kube API server as well. So basically all these ships, it's like a pool of ships. They're all trying to do their own thing, but they do have to communicate back to some central area of command, which stores all this information in this sort of etcd key value dictionary store. And with that, through these configuration files on how to, you define all these configuration files, like how to manage the ships, which ships should have which containers, how to tell if there's, what to do if there's an outage, etc. And how, how these ships should communicate each other. Maybe there's they open some ports, right? Some IP addresses, how, yeah. So all of these things, and kind of the management of this entire thing, goes through this Kube API server. So, I also forgot to mention that in general, security is is really important here in these containers or in these nodes. So when you create a node, when a node is created, it has a security certificate, which allows it to talk to Kube API and other ships. I think it's also possible for the certificate to expire. When it expires, I don't know what the default is, but when it expires, then the ship just kind of crashes and you have to restart the node. I think I might be wrong, and have to restart the node, which is probably a good idea. So security is kind of an inbuilt thing into these container into the CF of nodes, right? It's something that's built in. So Kubernetes, it's one of the main priorities of the Kubernetes API server. Like all sorts of malicious things can happen if you allow ships that don't have that aren't certified as secure to interact with your application, right? So hopefully that kind of makes sense. Thank you for listening, and I'll see you in the next one.